sometimes it's easier to calculate the complement of a probability rather than calculate the probability itself. Let's look at an example where this can help us solve a problem. We have an event E, with an associated probability of E. And we're going to say event E is, let's see, 5 coins are tossed and 1 or more heads show. So how many ways can this happen? Event E. We have 5 coins. We throw those coins out there. Well, let's see. We need 1 or more heads. So what if we had 4 tails and a head? That counts. 2 heads and 3 tails. That counts. Turns out there's a whole bunch of ways that we can get at least 1 head. Out here in the sample space, everything but event E is called the complement of event E. We're going to call it E prime, and it has a probability associated with it as well. And let's see, let's define this E prime, the complement of event E. Well, in event E, we rolled at least 1 head. 1 head, 2 heads, 3 heads, 4 heads, 5 heads. What's the alternative to that? It's rolling 0 heads. We're going to roll some heads. Okay, how many ways can this occur? Rolling no heads. Well, let's see. There's only one way that this can be done, right? We roll 5 tails. Right? Yes, that's true. There's going to be a whole bunch of ways that we can roll at least 1 head. But if we had an equation for the probability of E, in terms of the probability of E prime, the complement, that would be a little bit easier. And we do. The probability of event E is simply equal to 1 minus the probability of E's complement. And so we can write this. What's the probability of E? Well, it's 1 minus the number of favorable outcomes divided by total number of possibilities in the sample space. And I better solve this in the next line. It's going to be equal to 1 minus, well, let's see, the number of favorable outcomes of E prime, the complement, the number of rolling no heads. Well, we just figured that out. There's only 1 possibility, right? 1. And how many are in the sample space? Well, in this case, we have to use our, oh boy, I got to look it up. I hate when I can't remember things. But that's part of being an old fart. We need to use the fundamental counting theorem to determine how many possibilities there are when we roll 5 coins. And as you recall from our combinations permutations chapter, if there's 2 possibilities and we roll it 5 times, then there's 2 times 2 times 2 times 2 times 2 ways that those coins can roll. And that gives 2 times 2 is 4, 8, 16, 32. We have 1 minus 1/32. And so our answer is 31 32. Let's see if it makes sense. 5 coins are cost. If heads and tails have equal probability, what's the probability of rolling 1 or more heads? Well, since there's only 1 way we can lose, and there's 32 possible, we have a 31 32 chance of rolling 1 or more heads.